Welcome. Let's examine another problem-solving technique inspired by the American mathematics competition. This time I'd like to talk about a problem from the 2004 competition for 8th graders. And the technique we're going to do is draw a picture, which is one of my favorite techniques of all because most mathematicians, especially me, very much are visual thinkers, and most everything in my mind when I do mathematics is about a picture. It's a technique that's actually underrated, I believe, in the typical school curriculum, that we often don't have students draw pictures for problems, which is a shame because that's often a picture speaks 1,000 words, as they say. Anyhow, drawing a picture is a good way to model mathematics, and one of the Common Core curriculum practice standards is to model mathematics. Drawing a picture is a fine example of doing that. Alright, here goes. Alright, here's the question at hand. And step one in any problem-solving technique is just to read the question and have an emotional reaction to it. Here goes. At a party, there are single women and married men with their wives. Okay, only single women. The probability that the randomly selected woman is single is 2/5. What fraction of the people in the room are married? Okay, so I'm hearing the words probability and fractions and married men and single women or something, I don't know, stuff. I'm having an emotional reaction of, oh my goodness, this seems a lot. There are a lot of big words in here, especially if I think myself as a middle schooler. The word like probability and fraction are just scary. So I'm just going to have a deep breath and then see if I can work on step two, which is to reread the question and try to make some sense of it and its components. Alright, let's read the question again slowly. At a party, there are only single women and married men with their wives. Alright, so there are men at this party, there are women at this party. Some of the women are single, and some of the women, I guess, are the wives of men, and all the men there are married. Okay, so there's like three types of people. There are married men, married men's wives, and single women. The probability, that sounds very scary. I don't really know what probability means. That word scares me. I was going to say scary. That a randomly selected woman is single is 2/5. What fraction, the word fraction is scary too, of the people in the room are married. Alright, so those words are scary. I'm just going to be honest, say they're scary, and I'm just going to kind of ignore them. Alright, well that's fine, but my job now is to do something nonetheless. Alright, here's the technique I want to encourage. Draw a picture. Alright, can we draw a picture for this? Absolutely, we can draw whatever we like. Palm trees, unicorns, mushrooms, whatever. However, let's draw a picture that's relevant. One of the nice things about problem-solving techniques is that you can just do the obvious. What's this question about? It's about men and women at a party. Let's just state the obvious. So can I draw a picture of men and women at the party? You bet I can. So what I'll do is I'll just draw some men. I'll just write M for men. There's some men. I don't know how many there are. And there's some women. Great. There's a picture. I've drawn a picture that seems remotely relevant to the question. I have done something. I'm proud of myself for doing something. Can I make this picture more relevant to the question? So at a party, there are only single women and married men with their wives. Ooh, married men with their wives. So notice how I keep rereading the question, try to refine things. So let me see if I can make my picture reflect the fact there are married men and their wives. So that means maybe this man is married to this woman, so maybe I'll connect them this way. This man is connected to this woman. This woman is connected to this man. This woman's connected to this man. And here's I've got an extra man who's not with his wife. So let me draw an extra woman then in this picture. And there's some single women as well. So watch out, there's single women. So there's some extra women. Alright, there's a picture that seems to be more relevant to the problem. I've got married men and their wives and some single women. The probability, I'm rereading the question again because I don't know what else to do because I'm trying to make my picture look better. I'll make my picture look better by actually making it look neater. I'm not very good at being neat, I'm sorry. The probability that a randomly selected woman is single is 2 out of 5, 2/5. Can I guess what probability means? Alright, so it's about a randomly selected woman. So if I looked at the women here are the women. I've got at the moment 2 women out of 1, 2, 3, 4, 5, 6, 7. 2 out of 7 women are single. These women are single, these women are married. But watch out, it's 2 out of 7 women in my picture. I'm not quite sure what probability means, but I have a feeling my picture is wrong. I want 2 out of 5 to be married, to be single. Sorry, 2 out of 5. I think I've got too many married couples in this picture. So how can I change my picture so that I've got 2 out of 5 instead of 2 out of 7? Well, I'm just following my nose. Let me get rid of 2 couples. Beautiful. So now I have a picture of some married men and their wives and some single women, and if I just look at the women, 2 out of the 5 women, whoops, let's change this number here, 2 out of the 5 women are now single. I'm guessing that I've got a pretty good picture for the situation right now. Probability that a randomly selected woman is single is 2/5. I'm going to guess that's my picture. Alright, this is pretty good. In fact, I just drew a picture. I just did something obvious and didn't worry about details, and I kept rereading the question, refining my picture, and just following my nose. I don't really know what I'm doing, don't really understand all the words in the question. I'm just using common sense to get someone that seems to have meaning and relevance. Here's a pretty good picture. Alright, finally, at the party there's single women and married men with their wives. Got it. The probability that a randomly selected woman is single is 2/5. I'm guessing I've probably got it. Guessing what probability means. Finally, the third sentence. What fraction of the people in the room are married men? What fraction of the people in the room? So now I'm talking about all the people in the room. How many people in the room? 1, 2, 3, 4, 5, 6, 7. I've got 8 people in the room. 8 people in the room. And what fraction of the people in the room are married men? How many married men have I got? I've got 3 married men. Married men. I want a fraction. I want a fraction of married men and people in the room. Well, I'm going to guess the answer is 3/8. 3 out of 8 people are married men. What fraction of the people in the room are married men? 3/8. There it is. I'm going to say that is the answer to the problem. Voila. Alright, so there's a problem-solving technique that, this turns out to be correct, this is the correct answer, that allows students to basically follow their nose once they can sort of get past the barrier, of the emotional barrier of just needing to do something, and actually, make good sense of this. Now, as a teacher watching this go on, this discussion is totally fine, but I do have a question as a teacher. Is this the only picture that works? So let me just take this picture and sort of move it over a little bit, making a very messy board. So if this discussion was going on in my classroom and I was the teacher leading it, I might offer my students the following picture instead and see how they might respond to it. Man, 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 man. I've doubled the number of men. I'll double the number of women. Women, 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 women. How many? Oh, it's 5. I got down 10 women. Women, women, women. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This man is connected to this woman. These people are married. And the rest. So here's my question for my students. Is this picture of men and women also fitting the question? Well, let's see. Let's go through each sentence in turn. At a party, there are single women and married men with their wives. Yes, I've got married men with their wives and single women. I've got those 3 types of people. Yep, first sentence is done. The probability that a randomly selected woman is single is 2/5. So let's focus on the women. Here are the women. There are, how many women are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 women in all. How many are single? 4. 4 are single. The probability of me choosing one at random and her being single, I guess, is 4 out of 10. And from my earlier days in school, I happen to know the fraction's 4/10, the same as the fraction 2/5. It fits the second part of the question. So this is a different picture. I'm wondering now, do we still get the answer 3/8, or is this dubious? Could this depend on the picture? Well, what fraction of the people in the room are married men? There are 1, 2, 3, 4, 5, 6 married men. 6 men out of 6 plus 10, 16 people at all in the room. And if I know my theory of fractions, I can reduce this to 3/8 again. So actually, now we're on a wonderful, wonderful discussion about what's common about all these pictures of married men and women and single women. Do they all give the same answer, 3/8? In fact, this is a wonderful, wonderful discussion to have with students now about proportion and ratio, that you can scale up the same picture and all the ratios remain the same nonetheless. Fabulous. Actually, I really love this problem because I can give true ownership of learning to my students by saying to them, okay guys, how about we create our own picture first and come up with a question that follows it. For example, here's a random picture. Man, 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 woman, 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 and woman. Let's do that. Is that the same picture? Oh dear. It is the same picture. That's silly. Let's add another woman, and let's add another married couple. Okay, make up a question to confound your colleagues with, whose answer is basically this picture. And maybe the question is something like, at a party that contains only married men and their wives and single women, let's see, 8/11 of the attendees are married people. What fraction of the people at this party are single? Now that seems like a hard question, but there's a question like this problem that's based on this picture, and I bet you can work back and forth. If this is a wonderful idea, how many different questions could one single picture generate? Maybe all your students could look at this picture on the board and come up with their own questions and then challenge others to see how the answers will work. I love this idea of having them be in control of their own learning and creating their own problems to challenge each other with. In fact, this is a great way to see that mathematics is actually created. They can be in ownership of their created work and don't have to be feeling like they're at the whim of the textbook authors on which problems to solve. Let them create their own problems. Wonderful idea. This is a great problem. It illustrates the technique of drawing a picture. Even though the question itself wasn't even a geometry question, pictures are a very good way to model mathematics. All right, thank you very much.